So let's look at transistor level fault modeling. And basically, in case of transistor level fault modeling, the assumption is that a transistor is either stuck on, that means it means always conducting, or it is stuck off. It never conducts. And basically it is based on, it is derived from the fact that opens and shorts are the most common failure modes. And there are other failure modes which basically will cause the transistor to be either stuck on or stuck off. So we will assume that a transistor is either stuck on or it is stuck off, and we will try to see what will happen. So let us consider a circuit. Well, maybe you could just consider this circuit here. And let's consider this case. Here's an illustration. So this is consider the same circuit. And okay. Let us assume that the transistor, I have to give a transistor some names. So let me call this, how about I call this PA, let me call this PB, and let me call this NB, and let me call this transistor NA. Okay, let me ask this question. What will happen when transistor PA is stuck open? That means when transistor PA never conducts, what will happen in that case? This never conducts. So there's never a connection between here and here. So in that case, there will never be a direct connection between high and the output, right? So your output will never be able to go high. So what will happen is that, remember, once, that means once, but it can go low, right? This is still okay. So once the output becomes low, it is never going to go up high. So basically it is, for all practical purposes, we could assume that it is always low. So we could say that this means that output is effectively stuck at 0, right? Do you agree? Because there's no way you can make it 1, so once it is 0, it's going to stay 0. And okay, now let's consider another one. Now let's assume that NA is stuck open. What would happen? Okay, now we have to think about this a little bit. Okay, what will happen in this case? NA is stuck open. That means this will never be closed. However, notice this is working correctly. So this can close. So how can you test for this particular transistor being bad? If it is stuck open, how can you test for it? Now, one important principle in testing is that if it is stuck at something, if you want to test it, you have to get it in the opposite state so that you can make a distinction. So in order to test it, to sensitize output, So basically you have to make the output dependent on this. And to sensitize the output, we can choose AB equal to 1, 0. So this is 1, and this is 0. And basically, since this is 1, and this is an N channel, so normally this would be closed. Now in this case, this is open. This would normally be closed, and here you have okay, what can we say about between here and here? So we have PA, this is connected to a 1, so this is open, and this is closed, right? So notice that since this is open, so there's no path between here and here. And here, since this is open, output does not depend on this. And output will depend on whether this is working correctly or not. And if it is working correctly, you can say that the normal output is 0, because this would conduct and the output is going to be 0. However, if it cannot conduct because this is stuck open, in that case there is no direct connection between here and here, and there is no direct connection between here and here. So what would the output be at? So this is not connected to anything, so what happens in that case? Well, the answer is, okay, who has the answer? Answer is we don't know, right? That is the correct answer. And the reason is that it may depend on what was the previous value of the node. So all the output nodes, they have some capacitance. So whatever charge it has, it will stay there for a while. And in fact, that is the principle which is used for constructing dynamic ramps. So all the nodes have some capacitance, and whatever charge is there is going to, or charge or the lack of it will stay there for a while. So basically whatever is the previous value will stay. And in case of a fault, another fault we are considering. In case of a faulty output, output is equal to, well, and this is, you can say, it is floating. Now that is a term that electrical engineers use. It's not connected to anything, but actually it will hold the previous value. Now, let us suppose that the previous value was 0. Then the normal expected value is 0, and the previous, because of the previous value, it is still 0. So you will not be able to detect the fault. So in this case, what you need to do is to apply something before you apply this. So make the normal output, make the output equal to
Opposite of the
1. And then you apply this, and if it is normal, it will go from 1 to 0, otherwise it will stay 1. So this suggests that we need to apply at least a pair of vectors. So to test, so we actually, let me come here. So okay, so what we need is a test pair. Now incidentally, if you think about this, so what happens, now this is a combinational circuit, it's just a gate, combinational gate. But when you have this stuck open, it becomes sort of sequential. It remembers the past, so it develops some memory. And because of that, you need a test sequence. So you need a pair of vectors, and the test pair is going to be T1, you will apply a 0, 0, and the output in this case is going to be 1. Now this basically initializes, and test 2 is going to be this 1, 0, and in this case output is going to be 0 if it is normal, and 1 if it is faulty. This is the fault we are considering. This stuck open. So if you apply this pair of vectors, you have a way of testing for this stuck open faults. So this suggests that in some cases, because of some opens, it would be required to apply a pair of vectors, which will detect the fault. Any questions or comments? Okay, now let us consider the another example. Let us consider a stuck on faults. And so let me continue here. Okay, I seem to be going in the wrong sequence. I have started going right to left. I guess in some language, I guess the Chinese people do it. I guess depending on whether they're writing horizontally or vertically, and of course,
Yeah, we don't.
and
Arabic.
Arabic and Jewish people, they do it. But anyway, so as long as you can figure out where we are, so that is okay. Okay, step 1. So let's assume another example. Okay, let's same circuit, but let us consider PA is step 1, and okay, so this is the situation. Let's arrange these things. Actually, I should have drawn a different diagram. So if you're taking notes, you could copy that. But, okay. So let's assume that PA is stuck on. So this here is now stuck on. How can we test for this fault? And basically, again, if it is stuck on, you have to apply something different. So you could apply AB equal to 1, 0. So this is 1, and this is 0. And now, what will that do? Okay, this is 0, and this is a P-type of transistor. So this is closed. And this is 0, and this is an N-type of transistor. So this is open. And this is a 1. And this is N-type, so this is closed. Okay. And this is 1 and this is